Okay, so in this class we'll discuss these two questions. Class 9 Science, Chapter 9, okay, Force and Laws of Motion. So let me read the question 35. Go to page 120 of your tuition note. Okay. So state the law of conservation of momentum. We'll just read through this and solve the next question, which are related, okay. The law of conservation of momentum states that the sum momenta, the word momentum means plural, okay. Momentum is singular, of two objects before collision is equal to the momenta after collision, provided there is no external unbalanced forces acting on them. Or this can also be stated as the total momentum of two objects is unchanged or conserved by the collision. Now, in order to understand this clearly, we'll derive the equation for law of conservation of momentum, that is 36. This one is, I'll write the question even for us. Prove, okay, the law of conservation of momentum. So write along with me on your tuition copy. Now here there are two objects, so we are going to prove that this law is true. Okay, so here this is one object A having mass ma with initial velocity let us say ua, moving with this velocity, initial velocity. Another object also B moving in the same direction from left to right, as you can see from the arrow, with initial velocity of ub. So this is picture of before collision, before they come in contact with each other. They are running like this. The two objects are in the same direction, moving like this in the same direction. Okay. Now let us say this A is moving faster, and so finally catch up with B and collide. Okay, so this is the picture of when they collide. Just two. So they have collided. This is the object A moving faster, coming finally in contact with B. So when that happens, the force with which A acts on B, let us put it as FAB, and the force with which FAB, B, the force when they touch each other, the force exerted by B on A, let it be FBA, according to the third law of motion, that a force exerted by A on B will be equal but opposite in direction to force exerted by B on A. So this picture is at collision, okay, exactly when they collide. And after colliding, they touch, they will begin to separate again and move with a new velocity. So now let us say after collision, the two is now moving with new velocity. So this object A with mass ma will begin to move with a velocity of va, final velocity. Before collision it was ua. After touching, exactly after collision, they will separate and move with its own velocity again. So that is for A, final velocity va, and for the object B with mass mb, final velocity, let us say vb. So this picture is after collision has happened and the two objects has separated from each other. Okay. Now let us see here. Let us see here. So let us write down what we're going to solve. Okay, two objects here. Let us mention the objects are balls. Okay, balls A and B of masses ma and small mb, okay, with no other external forces. So these two should be moving with its own velocity. There should be no external forces interfering, okay, for this law to be proved. Because if it gets interfered, other forces get involved, then this law will not come out true, right? So with no other external forces, external unbalanced forces, okay, some forces are external unbalanced forces acting on them, okay, and in the same direction. They are moving in the same direction as in the diagram, moving from left to right, both of them same direction in a straight line. So they are following a straight line motion, not circular, okay, straight line, in a straight line, but they are at different velocities, different. So the two of them don't have the same velocities UA and UB, initial velocity UA and UB respectively. So since they don't have the same velocity, let us assume the body A is moving with a greater velocity, then UA is greater than UB, means this is moving faster than this one. So the second object will catch up with the first, only then they will collide. No? If this object is slower and they're moving towards the right, this object A will never catch up and there will be no collision, right? So during collision, let's continue next paragraph. During collision means this picture B. During collision, which lasts for a time t, which lasts for a time period of t, for a time t, ball A exerts a force, write it down, okay, along with me, exerts a force FAB, so FAB on ball B, on the ball B. So when they collide, A will exert a force on B which is equal to FAB, and this, according to third law of motion, is called action or action force, right? And ball B exerts, we're using third law, okay, now exerts an equal but opposite force, FBA on ball A, which is the reaction force. So the force exerted by B on A is FBA, which is the reaction force according to the third law of motion. So this third paragraph is explaining to you the third law of motion in play here, right? So now continuing with this, let us continue. Therefore, momenta, next paragraph, momenta means plural. Now we have learned that momentum P is equal to mass into velocity in our previous classes, right? Momenta of ball A before and after collision. Okay, after collision are, let us do this together. Formula of momentum is mass into velocity. So before collision is, the mass is ma into velocity before collision is ua. So this is the total momentum of object A before collision. And after collision, this is collision. After collision is here. It acquires a new velocity. The ball hits, second ball hits the first ball, and then both of them separate and begin to move with its own velocity again. A moving with final velocity. So mass will not change after collision. Also, you know the mass of the object, same objects of mass into final velocity. So this is the momenta of ball A after collision and before collision, m into ua, right, respectively. Okay, respectively. Now similarly, and respectively, and okay, and momenta, okay, momenta of ball B likewise before and after collision are just like we did for ball A. Before collision, mass of B is mb into velocity is ub. This is the formula, m into v. So velocity, initial velocity ub, mass into initial velocity, momentum before collision of ball B. After collision is this one, mb into vb, and mb into vb respectively. So this is what we're getting. Now question is saying to prove the law of conservation of momentum. So we need to know what exactly the law is saying. The law is saying total momentum of two objects moving with initial velocity, that is first one ma ua plus mb, second object, into, so that is the momentum of ball A, momentum of ball B before collision. Their total is equal to total momentum of the two objects. Even after collision, the total momentum will be unchanged. That's what the law is saying. That means total momentum after collision is this ma va plus mv, second object, momentum after collision, mb into vb. So total momentum before colliding and after colliding, also the momentum has changed for both of these. But when you total it, it is still the same as the total before the collision. That's what we need to prove. Total momentum of two objects moving with initial velocity before collision is equal to total momentum of the same two objects after collision also. So momentum cannot be lost, in other words, cannot be increased or decreased. That's what this law is saying. So we are going to prove this. So let's prove this. So let's write here to prove this. Proof means the answer. So here, rate of change of momentum, rate of change of momentum of ball B, of the ball or object B during collision, exactly during collision. Now rate of change of momentum is nothing but force only, which is FBA. So exactly at collision, rate of change of momentum during collision is the force exerted by B on A. Rate of change of momentum of ball B means the force exerted by B on A. Rate of change of momentum is force. So force exerted by B on A, because we're talking about B. So force formula is, we know, m into A, right? So mass of B, we write that one because we're talking about B, into acceleration. Now we know that A is equal to V minus U divided by T, right? So we can write here mass is mb, then V minus U, so VB minus UB divided by T, because we're talking about a B. Just as F equal to MA and M into V minus U by T. This A is V minus U by T, so there VB minus UB, because we're talking about the B. See here, UB, VB after collision. So this is the first formula. So we will write this one as equation number 1. Let us put this one as equation number 1. Okay, now similarly, rate of change of momentum of ball A during collision, which is FAB, will be equal to, for A, it will be mass of A into final velocity of A, VA minus UA divided by T, because this time we're taking for the object A. Now, we know that now, okay, we can just write here now, according to the third law of motion, to the third law, Newton's third law of motion, okay, according to Newton's third law of motion, FBA will be equal and opposite to FBA. Okay, let's write it here. FBA, which is nothing but FBA will be, which is the reaction force, will be equal, right, but opposite, okay, to the other one, FAB, which is the action force. We know that according to the third law of motion, for each and every action force there is an equal and opposite reaction force. So we can write here, that is, in other words, FAB, the action force, will be equal to minus FBA, because opposite means the direction is opposite. So if the force FAB is acting from one direction to the other, left to right, then this will be right to left, so minus FBA, because they're saying opposite, so opposite sign. So let us write that down now here. That is, we can write here, okay, so we can just write without this one, I think. Now here, so FAB in equation number 1, equation number 2 is MA into VA minus UA divided by T, this one, is equal to minus FBA means MB into VB minus UB divided by T. So since using equations 1 and 2, so now we can just cancel this T and T, because if you shift this, it will come numerator and cancel this. So let's multiply, plus into plus, plus MA into VA, plus into minus, here minus MA into UA equal to minus into plus, minus MB into VB, minus into minus, plus MB into UB. So this is what we're getting. So here now, let's write this one, MA into VA, minus come this side, plus MB into VB, equal to here, this one did not change, so MB into UB, minus shift this side, become plus MA into UA. So see here, this has been shifted this side, this 2 has remained same on the same side, this 2. So therefore, this is finished, or you can rewrite it, B, or we can write this one first. Here, see, this one first. Or you can write like this also. This one shift, then MA into UA, then this one plus MB into UB. Same thing only actually. So write that one. MA into UA plus MB into UB is equal to MA into VA plus MB into VB. So this is MAUA, MBUB, UU, you see. Total momentum of the ball A and B together before momentum equal to, after collision also, MAVA, V is final. Total momentum of the two objects when you put together is unchanged. So we have proved this. And this is an important formula we're going to use in solving numericals in the next class. Okay. There are 6 more numerical tests after this. So you please get through this carefully and they should be okay. I hope you got it. Okay.